right, Tim, thank you for that wonderfully generous introduction. I'm pretty sure Tim and I first met in the year 2000. I was in the process of trying to get an Astro Notes article in that column in the Physics Teacher published, and Tim was the editor, and then I saw his name tag at a meeting of the Cosmos in the Classroom 2000, and it took about 5 minutes of talking to him to realize we were kindred spirits. All right, well, I actually did send a title to Tim for my talk that was something more to the effect of formative assessments and tutorials, a winning combination. And I forgot to replace this long, boring PhD type title, which generally are meant to keep people from wanting to read your dissertation with that title. But I think that's really what I learned in the end, that it's all about having the students actually do something and then taking the time to figure out if what they did was actually taught them what you hoped that it did. All right, so let's go to the goals of my project were basically to develop and assess some solar system activities. And I wanted them to be learner-centered, active, and collaborative. Now, you may ask why solar system topics. Well, if you look at the greatest educational astronomy aid in the universe, which is a book of lecture tutorials put together by Tim and some other people, it's admittedly, I think even Tim will tell you, it's a little thin on solar system stuff. It's incredible on the motions in the sky. It's unbelievable when it comes to stars and light, and the most recent edition has just absolutely nailed cosmology with some of the work of recent PhD Colin Wallace from University of Colorado, who's now postdocing in Arizona. But anyway, there isn't that much on solar systems, so I thought maybe that's what I ought to concentrate on. So here's a list of 6 basic activities that were developed as part of my thesis. They were all developed and tested, and I think just about every one of them was published individually in a journal. There were 6 various publications: AER, the Physics Teacher, Physics Education, the Journal of College Science Teaching. So these things did get around, but we were working on them for a number of years. What I want to do is talk a little bit about each of them and how we tested them and how they seemed, how they seemed to pan out for us. Now, before you jump into, at least at James Cook, before you jump into a project whole hog, they wanted you to do a pilot project. And the research model I wanted to use is one that is espoused by Tim and Stephanie and also Janelle Bailey in their recent book, which I have read cover to cover a couple times, Tim, Stephanie. I'm sure you would assume that, about doing educational research in astronomy. And the basic idea is to have 2 populations and treat them a little bit differently and see if the results that you get in the end come out a little bit differently. And you can possibly tell then, is one teaching method better than another? Well, before they're going to let me try this with developing my own projects and my own assessments, it made sense to test the methodology with materials and assessments that were developed by others. So pretty obvious to me was this, although we're now in a new edition, but Tim and others' lecture tutorial book, and the unit that I wanted to test was stars. So here were a bunch of different tutorials, lecture tutorials, as I'm sure a lot of you know, are activities where students work through and are asked simple questions one at a time. They build on each other, and in the end, they figure a lot of things out for themselves instead of you just simply telling them, which they will forget. And yeah, I believe research shows students only hear about 10% of what you tell them, and 23 years later of being a teacher and a father of 3, I definitely believe that. Anyway, so what we did was we tried a couple sections where we did all these tutorials, and we tried a couple sections of students where we just lectured in the more traditional way, and we tried to compare them, and what we assessed them with was Janelle Bailey's assessment instrument, the STAR, I forget, did I put the name of that in there somewhere? I think, yeah, there we go, the STAR Properties Concept Inventory, and that was Janelle Bailey's thesis project. Tim, if I'm not mistaken, you were involved in that too, possibly even as her advisor when she was at Arizona, and you were as well. Anyway, when we look at some of the results here, the blue is the scores between 0 and 23 pre-testing, and the red is the students who were lectured to. And just so we didn't have the trouble with me getting overzealous, I did the lecturing, and I had a colleague of mine, Steve Morrell, good friend, and he's been invaluable. He's been willing to try every insane thing for me that I've thought of. He's the other full-time astronomy instructor at HFCC, and an adjunct, James Marks. They've just been great. They've again tried every nutty thing I've wanted to and taken data for me. And you can see that the students that were lectured to have a bigger spread, and the students who took the tutorials have a smaller spread, and also they're peaking slightly higher. And if you look at some of the data, here's pre-test and post-tests, and you can see scores weren't that much different, but there's not that much overlap. And the Hake gain, normalized gain, where you take the gain that you had divided by the gain that you could have had, was a little bit better for the students who took who did the lecture tutorials. So that was encouraging, and it did give us a reason to go on. All right, now what did we go on with? Well, there was a number of projects. I wasn't always the only one involved, but I was the one who generally wrote the assessment and designed the experiments. And the first one we got involved with was actually the baby of Steve Morrell, my colleague who I mentioned. He wanted a 10-year project, and I said, well, you know what I've always wanted around here? I've always wanted a walk-through model of the solar system, so why don't you spearhead getting us a walk-through model of the solar system. Now what you see is a badly outdated map of our campus, Henry Ford Community College in Dearborn, Michigan, which is Detroit is directly to the north and directly to the east as well, and the Rouge River. And we're named Henry Ford because this used to be his backyard. His mansion is still standing on the banks of the Rouge River, and the other half of his yard is the University of Michigan, Dearborn. Anyway, the science building, and in fact our planetarium is right here, so that's where we have the sun and the inner solar system in the science building, and then we have to correct size and scale, where the sun's about the size of a softball. Objects, Jupiter on the way to the student center is about the size of a marble. All the inner planets are pinheads, and all this stuff out here are a little bit smaller. This is our library, this is our tech center, and kind of an interesting twist at just about the time Tim and other members of the IAU decided to kick Pluto out of the Planet Club, our soccer field and baseball fields got plowed into parking lots, and we lost Pluto's position. So actually we've moved it over here to what is now green space, and we've changed it to display to the Kuiper belt. So things were, oh, I'm sorry, you can't see where I'm pointing. Is that better? And so I think sometimes things work out for the best. Anyway, enough yakking about that. What did we actually do with it? Well, we developed some questions about size and scale. Oh, you can't see my mouse. I'm sorry. I didn't realize that. We developed questions about size and scale, and we and we did this with all our assessment questions. We validated them by first we have students write out answers to questions longhand, and then we take our answers and our distractors from the longhand questions and see if the multiple choice questions came out similar to the longhand questions, and they usually did. But in any case, if you can look here, you can see the pre-test scores for various questions and the averages, and you can see the post-test of groups that went on the walk. And the students that received the lecture actually received a very good interactive lecture with softballs, basketballs, and objects. I think the sun, the Earth, Moon was done with a basketball and a baseball, but the solar system was actually discussed with the same size objects. And sometimes we even went out in the hall and paced a few things out. So it wasn't like we were just droning on about it. But as you can see, the averages of the students when on the walk were much higher outside the deviation, and you can see the normalized height gains were a lot larger as well. So we published that in the physics teacher, and in my thesis we actually ran a couple trials, about 3 trials of every one of these experiments, and sometimes changed up a few things. Oh, and these are the graphs. On the upper left, you see the percentages of correct answers and of the 6 questions, and on the right, normalized gains. And I'm sorry, I don't remember off the top of my head what was significantly different about questions 1 and 5, but I could probably look that up if I had to. I didn't. I was thinking I should do that, but I didn't actually get time to do that. But you can see it was a bit of a massacre, so the result we took from this was that if you absolutely have the opportunity, please have students walk through a solar system instead of just hearing about it. And the overwhelming comment that we've heard, and I'm sure you all have heard this kind of thing, is it just really blows their mind how much bigger the distances are than the size of the object. And I think this gets it across really well. One of the other fun things we do is made friends with a guy at a meeting who teaches at a community college near Phoenix, Arizona. And so we made an agreement to tell each other that our solar systems were the next one over. So like we tell our students that there's another solar system about the size of ours in Phoenix, Arizona, and in between here and there is nothing but interstellar space, and he tells his students the same thing. All right, now another activity that we did, this was the first one I ever actually developed. The first one I tried when I got back from that first meeting where I met Tim Cosmos in the classroom, where I first got bitten by the active learning bug. And I was really backing into it, but a lot of principles that I was using that I didn't even really understand. But anyway, the idea here was to take a set of solar system data, which you see here, and I just recently discovered the typo there. Jupiter's moon total at the time I took this table out of its source, Jeff Bennett's book, was 31, and I just recently read in Astronomy magazine that Jupiter's up to 67, so I'll have to amend that, but it really isn't a big deal for the activity itself. But the idea of the activity is that students, sometimes we have them make them, or sometimes we just give them the bar graphs, the histograms of the data, and we walk them through comparing the data, and we try to egg them on to see if they can come up with the planetary categories themselves, you know, so they notice, oh, there's some big planets and the planetary radii up there, or on the bottom there's some planets that are massive, others that are not, but then when we look at density, you see there's some planets that are dense, others that aren't, and then you say, hey, look, Pluto and Eris changed teams. You know, they're now over on the other side with the lower density objects. And it's really works fairly well at eventually getting them to come up with the terrestrial and Jovian categories. And one of the things that was kind of surprising to us is a lot of people would put Eris and Pluto together, Eris being one of the Kuiper Belt objects that helped drag Pluto down to its own level, so to speak, as a member of the Kuiper Belt. They put them in as a third category. Now, the thing about this that I mentioned that I kind of backed into was the idea here that in active and collaborative learning, since you're doing activities, you're going to have less time to cover things. And whenever you ask people, well, what do you leave out or how do you not cover things, that was always a hard question. I served on a, well, not in a committee, but I remember a group at a meeting in Pomona that was chaired by Bruce Partridge, and we tried to you know, admit what subjects don't you cover, what subjects don't you cover, you know, and it was like an AA meeting. Nobody wanted to really come out and talk. I finally had to use my abrasive, obnoxious personality to drag it out of some people. And anyway, one of the things that you don't need to do is stand there and read tables of planetary data to them. You know, you don't have to say Jupiter is this big, Saturn takes this long to orbit the sun. But you can have them use the planetary data, and they'll be exposed to the planetary data by using it. And then in my PhD research, I learned that this was called a knowledge-centered educational environment, because what's going on here is they're using facts, which are the planetary data, in a conceptual framework, which is putting them into categories to understand the different types of planets, and in the process they learn a concept, and that's one of the most useful ways to use content. Content is meaningless if you just throw it at them. It's much better if it's used in a certain way. All right, the statistics are not as strong on this one. I remember giving this talk at a AAPT meeting in Chicago, and I think Tim and Stephanie were in attendance. But it's been an activity that's worked fairly well for us. And one of the anecdotal things was this was always ones that students told us, especially when we were doing not as many active learning experiences. This was always one of the ones when we were just doing a few, students would say, hey, class was really cool today. And visual aids are neat in one like this too. We have beach balls of the different planets. And although they're not to scale, you can definitely see which ones are bigger, which ones are smaller. You can line them up, which ones are closer to the sun, which ones are farther from the sun. And I did promise to talk about formative assessments, and this was one, when we first submitted it to the physics teacher, one of the editors said, why don't you try some clicker questions? And I'm sure you all know about that. We do clickers with the colored cards, where you ask students questions usually the next day after you cover something, multiple choice questions, and they vote, and you see if enough of them get right, you go on. If not as many of them get them right, you cover it a little bit more. Or sometimes you have them discuss it, and after discussions, often the results of the votes get much better. But in any case, you're going over things, you're covering, you're reviewing things, and you're allowing students to figure out what it is they do and don't know, and you're also getting instructor feedback, and it's incredibly valuable because you can know, oh, I didn't teach this as well as I thought I did, or they need some more work on this. And sometimes it's shocking, things that you absolutely think you've got across, you didn't necessarily. And we found when we added formative assessment to this that the statistics did get a little bit better. All right. Oh, I'm sorry. And there's see the plots. They're not horribly strong. I'll be able to show you some stronger plots, more like the solar system walk, in a minute. The people who did the tutorials did outstrip those that did not by a little bit, but not all of it was statistically significant. All right, well, speaking of statistical significance, this, oh, and I meant to bleed out, those were referring to chapters in my thesis. I meant to bleed those out. I guess I didn't bleed them all out. what I call visual assessments has actually turned out to be something pretty similar to what Tim calls visual literacy tasks that are in every chapter of his book with Roger Friedman. I've developed a couple of these myself, and the idea is that the learning involved is very visual, that you have students either examine diagrams or construct diagrams, and then you also use similar diagrams for assessments. And we've found that this has been a really good way to get things across. Let me give you an example here. Almost 70% of the students, when asked to draw the path of a comet around the sun at 5 different points, and are instructed to show changes in the size of the tail, the direction of the tail, and the size of the coma, even after having read the solar system debris chapter where they saw a picture of what it was supposed to look like, again, 2/3 or more of the students still draw what I call this common head first, tail last misconception, which I think is a very understandable misconception, because when you see a picture of a comet or a meteor, and a lot of people don't have a clue about the difference between the two, you see a still picture of something that looks like it's streaking across the sky. So I really wouldn't blame anybody for thinking this. Now, here's a picture more like what we're shooting for, which is showing, again, that the comet's tail is always facing away from the sun because it's created by the sun's rays, and also that the coma will be larger and the tail will be larger when you're close to the sun. And here we were able to do some chi-square testing, because we're basically looking at did they get it right or not. And you can see some pretty nice p-values. Of course, I did learn from reading Tim, Stephanie, and Janelle's book that just because a p-value is really, really, really low doesn't mean something's really, really, really significant. It's just if it's underneath your standard, it is significant. If it's not underneath your standard, it's not. But nevertheless, these are significant p-values on the 0.05 standard. And if you look at the gains on the different questions, did they do the comet size, coma size, tail length, and tail direction, you see some pretty high Hake gains for the students that did the tutorials there. 0.85, 0.84, that's impressive there. And also the misconception, if you look down there, we started out with 68% of the students suffering from the head first, tail last misconception, and we were able to drag that down to just over 6% with the students who did this tutorial. Now, the students who didn't do the tutorial were showing pictures of what a comet's orbit is supposed to look like, but they, they didn't actually do the drawing. So clearly, doing the drawing seems to be an important step. Still a good number of them did not cure the misconception. And here's bar graphs of the same thing. You can see that questions 1, 2, 3, and 4 were did they draw the coma, the tail length, and tail direction. And question 4 is the misconception. So that went way down while the other ones went way up. And you can see the tutorial group just very much outstripped the people who were lectured to in both raw score and in normalized Hake gains. Another one is one of my favorite subjects is extrasolar planets and the Doppler detection method. And the idea is that by looking at the repetitions of red and blue shifts and the wobbles of the star that are caused by the presence of an unseen planet, you can learn the properties of the planet. And here on the left, you're looking at whether the planet is close to the star, far from the star, whether the planet is more or less massive. And on the right, you're looking at whether the orbit is circular, which would be a simple sine wave, whether the orbit is eccentric, which would be not a compound wave, but kind of a weird shaped wave, the middle one. And then you're also looking at a compound waveform on top there, which means the presence of extra planets. So this was the assessment that we gave before and after a tutorial that they did that was very oriented towards examining and looking at these kinds of drawings. And again, the results were fairly startling. You can see that we did much better with the groups that did the tutorial versus the ones that didn't. And what I mean by front and back there is the front was the 4 questions on the left, and the back was on the other side, the 3 questions on the right. And we looked at both what the percentages of the groups were that got perfect front, perfect back, and then a score total out of 7. And you can see that things worked out pretty well. I don't have a graph here of one aspect of it, but there was one semester where we actually looked at it 3 times. We looked at before, after, and then much, much later. And we found that much, much later there was a lot more retention in the groups who had done the tutorials than the groups who had done the lectures. So not only did they seem to get it better, it seems to stick with them a little bit longer. Okay, and there's plots of the data that we can hopefully call a win. All right, now, since I absolutely love lecture tutorials, again, a pedagogy pioneered by Tim and others in his lecture tutorial book, I thought I'd make a couple of my own to try to develop, assess, and test. And one already exists in Tim and everybody's book on the formation of the solar system, but I decided to try that on my own, a slightly different one. And this is both the graphs and also the data for that versus lecture. And we tried this a number of times. And you can see that in the red there probably shows up best in the normalized gains. And again, the questions are questions about the topic. And there are questions that we developed and we validated. Again, we'd ask students about, the questions in open-ended questions. We'd look at their answers and we'd pick some of their wrong answers to use as the distractors. And then we'd compare a post-test to see if, if the same distractors were showing up the same amount of times. Anyway, you can see the red, which was the tutorials, did outstrip the blues fairly well. And another tutorial that is kind of my baby, one that probably one of the first ones I wrote. This one, although there is some of it in Tim's book, this was about both the geological and atmospheric conditions of terrestrial planets. And the idea is to walk them through the steps of both getting through the ideas that the size of a planet or the mass of a planet affects whether or not it will attain an atmosphere and how thick it'll be, and also the idea that the mass or size of a planet is going to control how much internal heat it has to fuel its geology. So we had 10 assessment questions on that, and again, you can see probably most easily in the normalized gains that the red does seem to outstrip the blue. And again, we tried that several times, and we always ran formative assessments with these as well, where the next time, the way I run a formative assessment is usually it's the next class meeting after we've covered something, we do some multiple choice questions on the projector, and then the students vote on the answers and we discuss them if they have to. And we actually tried times where we did this and times where we didn't. And again, I say that formative assessment in any way, shape, or form is something I swear by, largely in that clicker format as well. All right, now one of the things that my advisor, Carl Pennypacker, God bless him, he sure helped me out a lot, was that we should look at some of the ideas of the students. What did they think of it? And so what we would call affective data. And for the most part, students liked doing things in an active and collaborative fashion. A lot of the comments that came up were things like, it forces us to think. It forces us to figure it out for ourselves instead of you just telling us. It's more fun to actually do something than just sit there. And those kind of comments came up repeatedly, so it's not just anecdotal from a student telling me. We saw a lot of that kind of thing. And there were some interesting comments on using the formative assessments, especially the voting on the projector questions. One that'll always stick with me was one student said something to the effect of, yeah, at first I thought that was going to be crap, but before too long I realized it really helped me learn. And another thing that they'll often say is that, a lot of teachers won't take class time to review, and a lot of students looked at it as reviewing, and it is. Our goal with a formative assessment is that we're trying to help students figure out what they do and don't know when there's still time to act on it. And of course for us, it's giving us feedback, telling us what we still need to do. But it is looking at something they've already learned and, seeing how much work they still have to do on it. So they really like that aspect of it. Although, you're never going to please everyone, because another comment that will always stick with me was one that said, well, he doesn't even teach. He just walks around the room while we do these stupid activities. So, it's nice to know you can never please everybody, so that way it still gives you something to shoot for. Before I share with you a little bit, I know I'm almost done here. We're supposed to go about 40 minutes. Before I share with you a little bit about what else we're doing now, I thought I'd just go over basic conclusions of this project. Was that this is something that I don't think anyone would say we don't know, but I just never had, I'd seen a few papers, but I'd never seen it done on this scale. So I really wanted to rigorously, with the solar system activities, which I felt needed to be developed and needed to be tested, see if students do better when they're doing these things. And I really think statistically we can draw, although some of the statistics were stronger than others, overall, and I did consult with a statistician when I was on sabbatical, University of Michigan, a psychology guy who was big on the quantitative statistics stuff. And he said I had pretty good statistical argument when he looked at what I had. And again, with the students, that they perceived that they were being helped, that this was worth their time, and it was good to do things like this. Now, I wanted to let you know that I actually submitted my thesis at the end of 2011. And 2012, ironically, was the first time I had an astronomy class since I had been back from my sabbatical. My sabbatical was winter of 2010, and that's when I wrote the first drafts. And after I went on the sabbatical, I spent a couple semesters teaching in our honors program. So I actually wasn't teaching introductory astronomy anymore at that point. So I had my friends Jim and Steve were running a lot of the assessments for me, and that was actually a good thing. That could eliminate what is often called the Hawthorne effect, where if I want a certain result, I might get overzealous about selling that result to my students. So having a full year or so of data where I was just the data collector and analyzer and I wasn't the teacher was a good thing. But anyway, after I submitted my thesis, I finally got another set of introductory astronomy students for the first time in like 2 years. It was good to be back with them, and I said, okay, well, I'm going to throw the works at them. I've got this entire solar system unit that I've developed and I've tested. I'm going to see how they do with it. And here's some of the results. I was very pleased. I just ran the data early this fall of students last winter, and you can see, like with the comet activity, got some very nice hate gains. Took the misconception percentage down from 41% to 9%. And then with the extrasolar planets, 0.6 is a nice hate gain. And overall, all of the different assessments of all of the different activities, there's 30 questions. So together we called that the solar system survey, those 30 questions put together, which we gave pre and post. And you can see there was pretty nice gain on that before and after. So we've got some other things going now as well. Here's a new visual assessment, the first one since my thesis that I'm working on. I just love planetary geology and planetary atmospheres, and this is an assessment that's trying to help them get the idea that how distance from the sun and the mass or the size of a terrestrial planet will affect things both geologically and atmospherically. So the questions that come with this picture are things like which planet probably has the highest temperature, which the lowest, which planet is most likely to have active geology, which planet is likely never to have had geology, which planet has the thickest atmosphere, which has the thinnest, which is most likely to be fully covered with craters, which has liquid water, which has ice. And we're still developing this one. In fact, this semester as we speak, we've given a pre-test and we're waiting to give the post-test till later because we want to be at least a month out of the solar system, and we're in the solar system right now. But you can see on the 17 questions, it's not as big of a hate gain as with the other things, but the percentages did go up a bit. So this is something we're still working on, and if things go the way they usually go in my life, you'll probably see this pop up in a journal somewhere. All right, well, thank you very much. Thank you, Tim. Thank you, all of you, for listening to me, and it's wonderful to get to do things like this. And anybody have any questions or comments? Be happy to discuss it. Thank you, Tim. I try. My advisor called me a powerhouse. That's a similar kind of compliment, that I'm a writing machine. Thank you. Oh, nice question there about doing online. Actually, some of these have been done online. For instance, there is a version similar to this online, and there's something similar to the one about extrasolar planets that was done online. And just a little bit of data. I think some of the extrasolar planet stuff found its way into my thesis. That the initial, here I go spazzing out on the PowerPoint, the initial results are encouraging, and yes, definitely should do some more of that. And then that's a big study that I'd love to do. We teach every semester about half a dozen sections online and in class, and actually I was just looking at Tim and Stephanie's and Janelle's book. You had that TOAST assessment in the back there, and that'd be kind of interesting to see how in-class versus online students do on an assessment like that overall, and see if there's a big difference between students that we never see and students that we see 2 or 3 times a week. Oh,
if you ever do that study, I'd love to help. I teach exclusively online.
Oh, do you? Okay, great.
Ever since I learned about lecture tutorials, I've been wanting to use them. I just can't figure out how to make them work in an online setting.
Yeah, that's the big difference. That you might hypothesize what would be the difference between the online students and the regular students. I guess some people call them on ground or whatever. But yeah, the fact that the lecture tutorials are not necessarily there. It would be interesting to see if that makes a big difference. I suspect it might. And someone asked about my N. The various parts of the study had different N's, but usually what would happen is a certain phase of the study would only be during a semester. So we'd start out with maybe as many as 100 or 150 students taking a pre-test, and then that would be broken into 2 groups, which we would have wished would have been 75 each, but with attrition would be usually less than that. So sometimes it'd be like 50 and 40 or 60 and 50 and stuff like that. And yeah, it would be nice to run. When you're doing a PhD, I found, even when you're in a position like I am, where I've already been teaching 20 years, you're still always feeling like you got to get stuff done, and you got to get, you're under the gun. And sometimes you feel like that when you're just trying to write an article too, but it would be better, especially maybe if we ever do this online versus on ground thing, to try to get a couple hundred data points. And I've done that a few times, where we have 200 or 300 as N. Did one study with seeing how the original astronomy diagnostic test did with our students, what it showed us we had to do better or what we were doing well. And another one on misconceptions, which a little bit found its way into this study. We had an N of about 300, I think. Oh, yeah, did we, one of the things, yeah, did we throw out people who didn't take the post tests? We didn't actually do that, no. We did, everything was blind. We didn't ask for people's names on anything. But yeah, that is something you definitely would want to do sometimes. But we generally just took, like, say if we had 5 or 6 sections, we'd get as much pre-test data as we could, and then we just get as much post-test data as we could, and we would compare the gains in the two groups. Any other questions or comments? Oh, good question there. Yeah, labs, discussion sections, how does that all work? Well, the community college, you're rarely ever going to find a discussion section. Basically, we have a class called Descriptive Astronomy, Astronomy 131, our version of Astronomy 101, and it's 3 hours a week, 3 credits, but we usually meet it in 2 80-minute blocks. There's night sections, there's day sections. I think we usually run about 6 or 7 a semester. And so that's, I guess, what you would call the lecture class. There's no separate discussion section like you would find at a university. And there is a lab. It meets once a week for 2 hours. And it's optional. We found most of the schools that our students transfer to, and if you're at a junior college, you're a slave to who you transfer to as far as what you can and can't offer and how you can offer it. Trust me, we learned that the hard way in some of our physics classes. Anyway, it's optional. Students can take it while they take the lecture or after, but they don't have to take it, and they can't take it before. And we offer both classes, both on ground and online. The lab experiences are largely computer, although we do have access to a telescope, and we do have some telescope activities. The on-ground lab class is largely built around playing with celestial globes and using planetarium software. And the online experience is with tutorials. With online tutorials that they complete. They're very visual, very active, and then they take quizzes on the tutorial. The lab is 1 credit. But yeah, there is an ambiguity, I guess, built into any data you would take at Henry Ford Community College, in that the kind of data I took doesn't discriminate whether or not the student took the lab or not, or will take the lab or won't. Yeah, the online tutorials, actually, I didn't write, although I wrote the activities to wrap around them. They're in Mastering Astronomy. I have the activities I'd be happy to share with you. You can email me. Tim's got my email, but it's really easy, lowpresto@hfcc.edu. Yeah, I could share with you the activities I wrote, and Mastering Astronomy, your Pearson education rep would be happy to get you activities for that. And as far as all this, I'm sorry, your Pearson rep would be happy to get you access to Mastering Astronomy. And as far as all these activities for the solar system, I've been giving them away to anybody who wants them. I've had a lot of people email me, and I'm more than happy to email the whole suite of them to you. Yeah, anybody who wants to, again, just let me know, and I'll fire them off to you as soon as I get the request.